This is a tutorial on simple probability. Probability is just a ratio of the number of specific events that give us an outcome that we want. And then that number of events is divided by the total number of outcomes possible. So if we have a probability equal to 1, the event that we're talking about will always occur. If we have a probability equal to 0, then the event we're talking about will never occur. Halfway between these, if we have a probability equal to 0.5, then the event we're talking about has an equal chance of occurring as not occurring. Now you can have probabilities of 0.67, you can have probabilities of 0.21. The numbers always range between 1 and 0. If you have a probability of 0.67, then you have a pretty good chance of the event you're looking at of occurring. If your probability is 0.21, then the event you're talking about probably won't happen. It might, but it probably will not. So the closer you get to 0, the less likely your event is going to occur. And the closer you get to 1, the more likely your event is going to occur. So let's look at a simple example. What is the probability of tossing a coin and getting heads? Well, remember, probability is the number of specific events that we're looking at over the total number of outcomes. If I toss a coin, I might get heads, or I might get tails. Those are the only two possible outcomes. So the total number of outcomes, that's equal to 2. Now the number of specific events, this is the number of ways we can get the result we're looking for. And the result we're looking for is getting heads. Well, there's only one way that can happen. That's when the coin lands heads up. So there's only one way that can happen, then our numerator would be 1. So our probability then, that's equal to 1 over 2, or it's usually expressed as 0.5. We got a 50% chance of tossing a coin and getting heads. Now sometimes you're not given a probability of an event. Sometimes you'll be given the odds of an event. Odds are a lot like probability, but there's one small difference. If we're talking about the odds of an event occurring, call it event A, then that's the number of outcomes that we're looking for. And instead of the total number of outcomes being in the denominator, it's the number of outcomes that are not what we were looking for. So again, if we were flipping that coin and we wanted to get heads, there's only one outcome, and that's when the coin lands on heads. But instead of the total number of outcomes being in the denominator, we count the number of outcomes that do not give us the result we're looking for. Well, again, it's either heads or tails. So there's only one outcome that doesn't give us the event we're looking for, and that's when the coin lands tails side up. So our denominator would be 1. So the odds of flipping a coin, that would be 1 over 1. Or sometimes you'll see odds expressed as a colon, a 1 to 1. Now sometimes you'll see odds expressed as the odds against the event you're looking for from occurring. Well, that's the same thing we did up here. It's just the reciprocal of the ratio we were talking about before. In our numerator, we have the number of outcomes that are not the event we're looking for, and in the denominator, we have the number of outcomes that are satisfying the event we're looking for. So in this case, if we wanted the odds against getting heads when we flipped a coin, then we'd have the number of tails occurrences, which would be 1, over the number of occurrences, or the number of heads that we might get. So 1. So let's work through some other examples of odds, or finding the odds. What are the odds that an ace is drawn out of a deck of cards? Well, if we have a standard deck of cards, there are 52 cards in that deck. And again, if it's a standard deck of cards, then there are 4 aces. So if we're talking about the odds that an ace is drawn out of a deck, well, then we need the number of occurrences in the numerator. Well, there's 4 aces, so there's 4 different ways I can pull an ace out of the deck. And in the denominator, that's the number of cards that we might pull out that are not an ace. Well, 52 minus 4, that's 48. There's 48 cards that are not an ace. So our odds would be 4 over 48. Or you can reduce this fraction. This is 1 over 12. So what are the odds that an ace is drawn out of a deck of cards? 1 out of 12. So what are the odds that an ace is not drawn out of a deck of cards? Well, remember, this is just the reciprocal of what we found before. In the numerator goes all the possible occurrence, or the number of possible occurrences that don't give us the result we're looking for, which is an ace. So there are 48 cards that are not aces. Then in the denominator are the number of outcomes that are possible, or the 4 aces in our deck. So what are the odds that an ace is not drawn out of a deck of cards? 12 over 1, or 12 to 1. Now let's go back to talking about probability. There are several different types of probability, and the first one we're going to talk about is the theoretical probability. The theoretical probability occurs when we know all the total number or possible outcomes of an event. So what is the probability of rolling a 4 with a 6-sided die? Well, a 6-sided die has 6 numbers on it: 1, 2, 3, 4, 5, and 6. So what is the probability of rolling a 4? Well, that's when we roll our die and we get a 4. That only occurs once out of a 6 total possible outcomes. So the probability of rolling a 4, that's 1 over 6, or 0.16 repeating. What would be the probability of rolling an even number with a 6-sided die? Well, we know all 6 possible outcomes of rolling a 6-sided die, and the even numbers are 2, 4, and 6. So our probability would be the number of outcomes that are even, so there's 1, 2, 3 of them, and the total number of outcomes, well, there's 6 of those. So we have a 3 over 6, or you can reduce that down to 1/2. So our probability of rolling an even number with a 6-sided die would be 1 over 2, or 0.5. So even though we're talking about theoretical probability, the way we solve for the probability is exactly the same. This is just the theoretical probability because we know every possible outcome of the total number of outcomes. Another type of probability is the experimental probability. Experimental probability comes from when we do many experiments and we get a probability of certain events in that experiment from happening. Then, if we were to conduct another experiment, we would assume that the probability of getting a certain result from that next experiment would be the same probability that we found from the previous experiments. Let's look at this example. Here we've surveyed several adults, and we surveyed them on the amount of time they spend watching TV per day. 79 of the adults watched less than 1 hour. 104 watched between 1 and 2 hours. 198 watched between 2 and 3 hours. 211 of them watched between 3 and 4 hours, and 312 of them watched for more than 4 hours. So what's the probability that a surveyed adult, if we surveyed another adult, watches more than 2 hours of television per day? Well, we don't know the probability of that particular adult. So what we do is we assume that the probability that this adult watches more than 2 hours of television per day is the same probability of all the other adults that we already surveyed. So to find this probability, we need to find all the total outcomes of adults that watch more than 2 hours. Well, these 198 adults watch more than 2 hours. These 212 adults watch more than 2 hours. And these 312 adults watch more than 2 hours of television. If we add that up, 198 plus 211 plus 312, that's equal to 721 surveyed adults that watch more than 2 hours of television. Now this is over the total amount of adults that have been surveyed, or the total possible outcomes. So we take this 721 and we add the adults that didn't watch more than 2 hours of television a day, so these 104 and these 79. That's 904. So that's the total number of possible outcomes. If you do this division, you'll come up with a decimal. That's approximately 0.80. So what's the probability, or the experimental probability, that a surveyed adult watches more than 2 hours of television a day? Well, according to the data in this experiment, there's a 0.8 probability that the next adult surveyed will watch more than 2 hours of television per day, or an 80% chance that the next surveyed adult is going to watch more than 2 hours of television per day. Now again, we calculated our probability exactly the same way we always do. This is just the experimental probability because the probability of the next event is based on the previous events or the previous experiments. Now the last type of probability that we're going to talk about is the geometric probability. And to illustrate the geometric probability, we're going to use the classic example of throwing a dart at a dartboard. So if a dart is thrown at a dartboard without aiming, which means it has an equal chance of hitting any point on this board, what's the probability that the dart will hit the bullseye? Well, to determine this, we use the area. The area of this dartboard, well, its width is 40 inches and its height is 40 inches. So the area of the whole dartboard is equal to 40 times 40. And that's equal to 1,600 inches squared. So this is the total area, or the total area possible for the dart to land. So think of this as the total possible outcomes in our probability ratio. Now the total possible events that satisfy the condition we're looking for, which is hitting the bullseye, well, our bullseye has a radius of 1 inch, and it's a circle, so we can find the area of the bullseye. The area of the bullseye is just pi r squared. Our r is 1, so the area of our bullseye is pi 1 squared, or 3.14 inches squared. So the geometric probability of hitting the bullseye, well, that's equal to 3.14 over 1,600. Find that in decimal form, and that's approximately 0.002. So the random probability of throwing a dart and hitting the dartboard in the bullseye is less than 1%. It's a 0.002 probability of hitting the bullseye. So that's the geometric probability, and that completes the tutorial on simple probability.